In this video, we're going to be looking at the results for maximizing the NPV with the 10 sequence Antarctica dataset. So first of all, make sure that you have actually selected the Antarctica mine and the 10 sequence version of it. There is a 1 and 2 sequence, but make sure you've selected the 10. Now, we're also going to be just looking at the base case schedule. We're not looking at the different objectives or some sensitivity studies. So we're just looking at the results for maximizing the NPV, which is the base case. Now, there's a whole lot of input parameters. I'll let you have a look at those at your own time, but we're going to focus on the results here. There's 4 sets of results, really, when you have a look at these. The first set of results is in this little table at the top. Now, the most important number is put at the top, the net present value. So it's in bold, it's strategically placed at the top because it's the most important number. The net present value is the best proxy for measuring the shareholder value, so that's why we've put it at the top. Now, the life is also quite an interesting little metric. It's not as important as the net present value, but it's amazing how you can see into what's happening in the schedule by looking at the mine life. So if a constraint changes, like if you increase a capacity for one of your processing capacity or your mining capacity, your mine life will normally go down. If you increase the prices, often the mine life will go up. So you can get this bit of a feel for what's happening inside the schedule by looking at the mine life. So it's quite a neat little proxy that you can use or metric that you can use to see what's happening into the mine life. Likewise, the amount of ore is also an interesting proxy. It's similar to the mine life, will tell you how much ore is being processed. It's quite a useful piece of information just to know when the mine actually stops. The next graph is a chart of the mining sequence. On the left axis, we've plotted the mass moved, so the total rock moved as the schedule advances. So you can just hover your mouse over these and you'll see the time and the rock mass mined in that period, or the annualized version of that rock mass. And you'll see also in blue the annualized amount of ore at that time. The third piece of data on this chart is the cutoff grade. So this is displayed on the right hand side. In this case, it's the cash flow grade, and in dollars a ton. You can see that this is what's called a variable cutoff grade. So when you optimize the cutoff grade so that you maximize the net present value of the project, you often end up with these variable cutoff grade policies. So people often think that the cutoff grade should decline with time. And although generally it does kind of decline with time, there's periods where it increases as well. So that's why it's not called a declining cutoff grade, it's called a variable cutoff grade, just because it goes up and down depending on the rock that's being mined and the remaining material and the costs and the revenue, and all those things are being taken into account to try to figure out what cutoff grade you should be using and how much of each capacity you should be consuming. Now, the next chart is an annualized cash flow chart. So in this chart, you can see from the zero base here, you can see what the revenue is as the schedule advances. And then you can also see the costs over time. You see the costs are quite flat in this one. The revenue actually goes up and down. And the blue is the profit over time. Now, interestingly, if you have a look at this period here, around 2021, you can see we've got a profit of about $1 billion a year. And that equates to a discounted cash flow, which is the final series on this chart, a discounted cash flow of $824 million a year. This shows the time value of money. If you go along to another period a little bit later, it's still about $1 billion a year, but the discounted cash flow is only $350 million a year. So it shows that time effect on the cash flows. It's an incredibly significant effect, this time value of money, and it's often missed because people often just look at these total cash flows and they miss that actually the discounted value of those cash flows is getting lower and lower every year. The final report is a much more detailed report on exactly what's happening to the pieces of rock as they're mined. So we have a summary of the report here with things like the cash flow, the cut-off grade, how much material is being mined, how much goes to ore, the metals being produced, the costs and revenues. But you can also expand this report to see all the individual little pieces of the increments being mined and how much of those were sent to the mill, what the cut-off grade was, how much metal there was, what the costs were, and so on. So if you really want to know exactly what happened at each period, this tells you for each little piece of resource that we schedule, what happens to it. And then we also have the closure costs at the end and the initial capital injections at the start. But often the main thing you want to know is just these statistics from the table here. So we're going to be looking at different objectives in the coming videos and sensitivities and things like that. So feel free to leave some comments below and we'll catch you at the next video.